So we had answered 4. And 4 was when is the particle speeding up. So that should be your hint to figuring out when it's slowing down. Now, pause that thought. Do I need to address 4 a little bit better? Because I feel like I flung that answer up and, okay, it's coming back to me now, okay? So 4, we flipped back in the notes a couple of pages and there was that table, when does something speed up? And a particle is speeding up when velocity and acceleration have the same sign. Okay, now, what you have to remember here is we are looking at a velocity graph. So velocity is based on where the location of the graph is, right? When the graph is above the x-axis, velocity is positive. When graph is below the x-axis, velocity is negative. What's acceleration based on? Acceleration is the derivative of velocity, so that means acceleration is the slope. So like here, where it's constant, that's a slope of 0, negative slope, and positive slope. So where are they the same sign? Either where are they both positive or where are they both negative?
From 1 to 3.
And that is not from 1 to 3.
2 to 3.
From 2 to 3?
Oh.
Right here, because my velocity is negative because it's below the x-axis. My acceleration is negative because it has a negative slope. Okay, so this right here in this section, we have negative velocity and negative acceleration. Okay, so that was for speeding up. When is it slowing down?
3 to 5.
Well, what are we looking for? We're looking for opposite signs.
Is it also slowing down? No, because they're opposite
But
sides.
it's positive and it's decreasing, so is that opposite? Yes.
Okay, let's analyze. So let's go through each section. Up here, you would have a, what? Positive velocity, but a 0 acceleration. Here we have positive velocity and negative acceleration. We already did negative, and here we have a negative velocity and a positive acceleration. So where do we have opposite signs?
And 3 to 5.
1 less than t less than 2, and 3 less than t less than 5. So yes, 1 to 2 and 3 to 5. We getting it?
Honestly,
Okay.
I like this business gonna get.
When is velocity increasing?
2 to 5?
I was looking at
1
And why?
because it's below.
When's velocity going to be increasing? When what is happening? What'd you say?
When it's above the.
No. Velocity is going to be positive when it's above the x-axis.
I just did what you said.
acceleration is positive.
Okay. We are looking, if velocity is increasing, that means your acceleration is pushing it to increase. So that means your acceleration is positive, and acceleration is positive on the interval from 3 to 5. Are you with me there? Now, I'm going to be flipping pages back and forth. Look at your next question. When is the velocity decreasing?
1 to 3.
Because my velocity is decreasing when you have when your acceleration is less than 0. Okay, because then your velocity is being slowed. And so we have negative acceleration from 1 to 2 and 2 to 3. So yes, we can say 1 to 3. So because it was decreasing, we're looking for acceleration less than 0. And that does happen on the interval from 1 to 3. Okay? Number 8. And again, look in your book notes because you guys have it mine's going back and forth. Are your answers to question 6 and 7 the same as your answers to 4 and 5, respectively? Explain. So first of all, are they the same?
No.
No. 4 and 6 do not match up, and 5 and 7 do not match up, right? Is that what they mean?
I think so.
Yeah, because speeding up, increasing, yes. Explain. So, okay, I got the first part. Why not?
Explain. They're just not the same.
Okay.
They just don't match up.
So,
They're not the same.
I was asking different questions.
okay, fair enough. It is asking different questions, isn't it?
Their velocity.
Yeah.
Like,
When we're talking about velocity increasing or decreasing, that's based on when acceleration is positive or negative, right? Okay. Whereas, yeah, speeding up and slowing down, it's not based on just the acceleration. Okay. So I have written on mine, no, velocity increases where acceleration is positive. I'm not really sure how that's explaining. I mean, I guess, velocity increasing, decreasing is not the same thing as speeding up and slowing down. Is that a good way to put it?
Yep.
I don't, Velocity increasing / decreasing is not the same as speeding up, slowing down. Okay. So 9. How fast is the particle moving at time t = 4? And in what direction?
-5 meters per second, which would be. Oh, wait. Because it's negative.
I'm sorry.
So how fast? What are they asking us here?
Velocity.
Rate of changes.
Not just velocity, but
Speed.
speed. Okay. When they're talking about how fast is something moving, we are thinking speed here. Now, when we talked about speed last week, speed is what in relation to velocity?
Absolute value of velocity.
Yeah, speed is the absolute value of velocity. And we're looking at velocity when? At time 4. So we want the absolute value of the velocity at time 4. Now, I think you guys, dang it, I went the wrong way. Velocity at time 4. You guys already did this, yes? You're looking right here, and it is lining up with -5. However, we are smart cookies, and we know the absolute value of -5 is 5. So how fast is a particle moving?
5 meters.
Okay. I'm just going to say 5 because, I guess, well, first of all, it wouldn't be meters per second.
Oh my god.
feet per second.
It would be feet per second because that's what it would label. But I don't even have it labeled. I just have 5. In what direction?
Left.
Left because it is a negative, yes? And actually I have written down in a negative direction. Now, what is the negative direction? That does translate to being left. Well, and that's the thing. Here, we're talking about a particle moving along a coordinate line in the directions. And so that informs left or right. But that's the thing. In a negative direction, if we're in an up-down manner, would be moving down. And so you have to look at the situation.
So,
But it does specifically say coordinate line up top.
so what would the line up and down be instead? Because the coordinates left and right are
I don't know. I don't know how it would be stated. Okay. What is the particle's velocity at time t equal 4?
negative 5.
Okay. So this one is just v of 4 equals negative 5. Okay. And again, what does that negative value indicate? Same thing, right? Negative value still indicates moving left. But it's just with velocity, you would give a negative. You can give a negative answer. Okay. Average velocity. What is the average velocity over the time interval from 2 to 3? Thoughts on how we're going to find average velocity?
A-Rock.
A-Rock, yeah.
Okay. So A-Rock would be a good way to think about it. What are we checking here? What is velocity? It's what over what?
Distance over time.
Distance over time. So if we're doing A-Rock, and you're subtracting on top and subtracting on bottom, right? It's change in the distance over change in the time. So I'm going to use delta to indicate change in distance over change in time. I think that's what I had done in my notes. Now, this is on the interval from 2 to 3, yes? Gosh dang it, keep going the wrong way. Okay, so interval from 2 to 3.
2, 0, and 3,
Wait a minute here. Okay. So maybe I shouldn't have used. Okay. So change in distance. So I want it. So I have change in distance. I have delta distance written down, and I guess maybe I shouldn't have put the delta on there. But okay. So generally speaking, velocity, distance over time. Yes. Now, what we have to look at as we talk about that change in distance, we're talking about the total distance. And when we talk about this graph, see, here's the deal. When we talk about this graph, how do I want to explain this? This isn't your distance here. This is velocity. Okay, so it's not just, okay, it went from 0 to 10, or to negative 10. Okay, so when we talk about our total distance, you flip back to, what, 145. What does the area under the velocity versus time graph tell you about the motion of an object? And that was that it is total distance traveled. And that's what we want to look at here. So we're looking at the fact that total distance is going to be the area. Okay, area under the graph. Now, we're still looking on that time interval from 2 to 3, yes?
Mm-hmm.
So as we look at that time interval from 2 to 3, what are we looking at here?
Triangle.
Yes?
So we had a area of a triangle, which is 1/2 base outside.
Okay. area of a triangle, 1/2 base times height. What's my base?
1.
What's my height?
Negative 10.
What 10?
10.
What 10?
Negative 10.
It is negative 10.
Oh, I was right.
Okay. I heard both at the same time. That's what I was trying to clarify. So when we talk about this total distance traveled, it's the 1/2 times the 1 times the negative 10. Change in time, that is still the, went from 3 to 2. That is what that axis is. So we end up with
Negative 10.
Okay. One of those easy things to forget when you're talking about total distance on a velocity graph, you have to look at area under the graph. In this case, it makes sense. It should come out negative because you are below the x-axis, right? Okay. 12. When does the particle change direction?
2. And 5.
Out times 2.
Why are we giving these answers?
Because they're zeros.
Okay, so when is particle going to change direction? It's going to be when
It stops.
velocity is 0. Now, we want to specify here it's not just when velocity is 0, it's when velocity is 0 and changes from positive to negative or negative to positive. Because I'm going to rule out one of Doug's answers here.
Is not 5 and 3.
Because, okay, everyone was saying 2.
Yes.
Well, I don't know about everyone, but I heard that as a common answer. Yes? 2 because velocity is 0. What's it doing? It's changing from positive velocity to negative velocity. So that's definitely a change in direction. At 5, it is 0. But before that, it is a negative velocity. What about after 5? We don't know. Is the object just done and it stopped? Does the object continue with positive velocity? Does the object continue with negative velocity again? Like, we don't know what's going on here. And so for that matter, we're just going to give the answer of 2. If you want your hint, changes from, well, that should say velocity changes from positive to negative or negative to positive. I don't know. Write it how you want it. But basically, it is the x-intercepts on a velocity graph, right? We're on a velocity graph right now, and so it is your x-intercepts. Just do keep in mind, all of this we're doing is on a velocity graph. Okay. 13 when you're ready. How far does a particle move during the first second, and which way?
The 5 feet. Or 5 feet. In the positive direction.
So first second, we're looking at right there, yes?
It doesn't move at all, does it?
What is this graph representing?
Velocity.
Velocity. So it's moving, it has a velocity of 5 what? Feet per second. So in 1 second, it is moving 5 feet. Make sense? Okay. I have 5 units. I have written down 5 units right, so in a positive direction. I don't know why I didn't really use the labels on here, but I didn't. 14. How far to the right does the particle go, and when does it arrive there?
Would that be
It's going to be more than 5.
2?
To what? For my answer? So when is my particle moving to the right?
0 to 2.
When velocity is positive, so from 0 to 2, yes? So when is it? How far does it go? We haven't gotten that far yet. But when is it going to arrive there?
2 seconds.
At t equal 2, right? Now, how far does it go? We're not talking, so how far does it go? We're talking a distance. How can we find a distance here? How did we find a distance?
That's an area of trapezoid.
Okay.
Yeah.
That's harder than I want to think about.
Triangle on a square.
Yep. Either way, can't get to the right screen. We're trying to figure out this area here, yes? Whether you see a trapezoid and you remember the area of a trapezoid, or whether you say, I have no idea how to find the area of a trapezoid, so I'm going to do a square and a triangle. Pick your choice. Pick your poison, right? That's what I want to say. Pick your choice. So for me, I honestly might do a trapezoid, but I'm not going to for you guys. From 0 to 1, what do we know?
1,
Width 1 and height
5,
5. From 1 to 2, what do we know? It's a little triangle.
height 5,
1/2 times the width of 1 times the height of 5. What do we get?
7.5.
Okay. 7.5. So how far right does the particle go? 7.5 units. When does it arrive there?
Equals 2.
At t equals 2. What is the total distance traveled by the particle? Well, we already know part of it, don't we? What do we already know?
We know the first part.
We know from 0 to 2 seconds it went 7.5. What else do you know?
We can do another area of triangle.
We see a big old triangle here if you want. What do you know about this big old triangle?
Height negative 10 at base of 3.
1/2 times 3 times 10.
15. Negative 10.
What if I just say plus 15?
Where'd you get 7.5?
it was the
From
14?
the trapezoid.
Right here we did 0 to 2 seconds and it came up 7.5. Does that make sense? So right here this was my 0 to 2 seconds and that means this is my 2 to 5 seconds. I was trying to use what we already have. Like why redo what we've already done?
So since it's total distance, it's absolute value.
Okay, so totally get why Doug's trying to tell me negative 15 because it is in a negative direction. So that 7.5 is in a positive direction. The 15 is in a negative direction, but did this ask me where the particle finishes? It doesn't ask me where the particle finishes. It asks me total distance. So if you go 7.5 units forward and 15 units backwards, does that mean I've only gone the distance that doesn't overlap? No, I've walked all those steps, haven't I? So we're going to go positive there. And so that puts me at 22. Okay. What is the particle's position after 5 seconds?
Undefined.
So. We don't know.
Yeah, we do.
Yeah, we do.
0.
What did it do from 0 to 2?
Right, 7.5.
7.5, right. What did it do from 2 to 5?
Oh, wait.
It went left 15. 7.5 minus 15 is
Negative 7.
-7.5. Or if we take off that negative, this is 7.5 units to the left.
It's not asking what it's doing after 5 seconds.
And it's tricky, isn't it? That was total distance. We use the same numbers we did here for its position. But I've explained myself, right? Whether you like it or not right now. Some of you are not liking it. Sorry. Okay. Continuing.
Might be shed over this more. Like this, I haven't tried yet or calculus like at all.
Okay. What is the average velocity of the particle over the 5-second interval? Well, what did we just figure out?
This
How
is the
far?
mean.
So distance over time, it should be 22.5.
Which distance do we use?
We use the total distance.
Okay.
No?
No.
Position, the final position?
Okay.
Why is that?
Because, well,
Because
We're not being asked total distance because we're not for average velocity. So for average velocity, we want to use. How do I want to say this? So I'm getting ready to contradict myself if I say it that way. We have to look at that change in velocity. Okay, it went 7.5 to the right, and then it went 15 back, right? Or correct? Sorry. And so that 7.5 minus 15 is that negative 7.5 over what time interval? And that is 5. So I know that's not the answer I wrote down. Negative 7.5 divided by 5. I've written down as negative 1.5. There's the word I needed to talk about. Displacement. That's the word that I was, so, and part of this has to do with we have a positive and negative velocity over that 5-second interval. But this one is talking about displacement because there is over the 5-second interval. And I'm mentioning that because I just looked ahead to my 18. Are your answers to 15 and 16 the same? No, they're not the same, right? We just, wait, 15 and 16? Well, regardless, they're not the same. And 15 was total distance, where 16 was the position. And when we talk about the position after, we're talking about displacement. So I have written down no total distance versus displacement. Okay. Total distance was on question 15. Displacement was on question 16.
What's displacement?
What?
What's displacement? Like, what's the
We defined it somewhere, didn't we, or did we not? We talked about it. Did we not define it?
We talked about
You
it.
get displacement, like,
This didn't come up later.
So
how do I want to explain that? I thought we did, so that's why I can't.
so total distance is equal no matter overlapping displacement.
I mean, displacement, you want to think about the difference between the two, because it's kind of, okay, what's left after you displace, like, after they cancel each other out, yeah. I'm looking for a definition here to see if it would help. Displacement, the moving of something from its place or position. That doesn't really help me much, or just a general.
It's
like when you drop a rock and top. Is it it's
and it means
Displaced.
displaced. Yep.
like ACTO.
Okay.
Because
I guess
before you check the water head rate, distance or distance. No. If you drop a rock into water
Trying to figure out
and it rises, the volume rises, and then you subtract it from the water from before to get the displacement of the rock.
Oh,
like the rock displaced how much of the water then.
that makes sense.
So that's how
I
you
mean,
find
it's-
displacement for displacement.
Yeah.
I don't know
And I need
how that works.
I'll have to work on a better definition. Because in my brain I just think of it as the difference.
Nope.
You know? Like when I walked 7.5 one way and then 15 back the other way, okay, what's the total distance was walking both ways. The displacement is the difference between the two because it's how far am I displaced from where I originally started.
Yeah, that's how I
Is that a good way?
How far you are from where you originally
Yeah,
started.
displacement is just what's your whole result, or what's your final result
From where you started.
from where you started, right? Okay. So it's not a good definition I have in my mind. I'm not the science teacher here with the,
Go ask Mr. Kevin.
Honestly, yeah.
And he might have
Okay.
Next time. He will.
Okay. Average speed. What is the average speed over this 5-second interval? What?
1.5 meters per second.
well it's
Well, so average speed over the 5-second interval is going to be all the place you travel. So if we're talking average speed, you want to think about
Total distance.
distance over time. What is the distance you traveled over a 5-second interval? It all matters.
22.5.
22.5 over the 5 seconds, which is 4.5 according to my notes. Okay. Ooh, we got 20. What is the particle's acceleration over the first second?
0.
Do we agree?
yes.
Because over that first second, my line is constant, horizontal. That means the slope is 0. So acceleration over the first second is 0. What does that mean? What's that mean about my velocity?
It's constant, right?
Velocity is not changing. It is constant. Okay, I feel like we've already talked about some of this. A couple easy questions coming up. Over what time interval does the particle have positive acceleration? We already talked about this.
3 to 5.
And why 3 to 5?
That's when acceleration is positive. Good job,
That's
Kylie.
just always positive.
That's because when your
A is greater than
slope derivative, right?
Well,
V prime is greater than 0. Yes, acceleration is greater than 0, obviously. Or how about velocity is increasing? Over what interval does it have negative acceleration?
1 to 3.
1 to 3, they say. I'm trusting you. I haven't checked 20 because I don't have the graph in front of me anymore. Okay. When is the acceleration undefined on the interval from 0 to 5?
3.
And?
1
And?
and 5.
5's not included in this interval, though.
Oh, it's not.
2.
Oh, no.
Would it be 2?
Okay, so we just mentioned several places, and I'm not sure if we've got them all or not. We'll check that here in a moment. But what are we looking at here?
The cusps.
The cusp, because acceleration being undefined means the derivative of velocity. When is a derivative undefined? At cusp, at sharp corners, at asymptotes. We don't have that, but you know. So acceleration, so basically we want to know when is the velocity, or the derivative of velocity, undefined. And that is at cusp, or sharp corners, and that is t equals 1, 2, and 3. We're not including the endpoints of 0 and 5 here because they're not included in my interval. My interval does not, it just says from 0 to 5, not including the endpoints. State an interval of time when the particle has positive acceleration but is slowing down.
3 to 5.
Okay, so positive acceleration, we already mentioned positive acceleration, yes? That's 3 to 5. But is slowing down. When does it slow down? Slowing down is when the velocity and acceleration have opposite signs, yes? Now, on 3 to 5, we have negative velocity and positive acceleration. Okay. 25. State an interval when the acceleration is negative, but the particle is speeding up.
2 to 3.
Speeding up means that acceleration and velocity have same signs. Okay? But you need to make sure acceleration is negative. Now, do we have... Those are the only places, though, aren't they? Okay. What is the particle's acceleration over the time interval from 3 to 4? How do we find acceleration? Slope. What's my slope?
-1 foot. Or 1 foot.
We're going to rise how much?
5.
5. We're going to run how much?
1.
And that is?
5.
I was thinking of the opposite way.
Doug is upside down. So, the derivative of velocity is acceleration, which is 5. Okay. Okay. What is the particle's average acceleration over the entire 5-second time interval? Okay. Average acceleration. Now, this one is acceleration, folks. Did you catch that? Acceleration is going to be change in velocity over change in time. We have all this information in front of us. So this is your, you can think AROC here. Because we can think it's over the 5-second interval. So the velocity at the end minus velocity at the beginning over, wait a minute. Yeah. Over the 5 seconds to 5 minus 0. What is my velocity at 5?
0.
Minus, what's my velocity at 0? Over 5 minus 0, what do I end up with? -1. And again, this is because it was asking for average acceleration. Earlier it asked for average velocity, so that was distance over time. Average acceleration is going to be velocity over time. And over what time interval is the particle's velocity decreasing at a rate of at a rate of 5 feet per second every second? Now, 5 feet per second every second. Realize that is their way of saying 5 feet per second squared. Which that is a label for what?
Acceleration.
Acceleration, yes? Now, it did say decreasing, so what do we need here? A negative. Now, I said acceleration. How are we going to find acceleration? That's going to be the what?
Velocity or time?
Well,
Are we asking?
just looking for the slope, right? Acceleration is the slope of velocity. So when is my slope negative 5?
1 and 2.
Is he right? There's negative 5. This one is,
Negative 10.
so yeah. So 1 to 2. Okay. We have to work on those guys. Whew. Okay.
I hate tables. I hate graphs. I hate anything.
So you hate calculus.
Yes.
No, these graphs.
Calculus is a lot of tables and graphs. I
These
mean,
graphs suck because, oh my god,
welcome to calculus. Okay, gotta move. I've got like 10 minutes to finish 2.5 pages. So, complete the table below to find all the possibilities for an object's motion. Remember that an object's velocity is either positive, as in moving right or up, or negative, moving left or down, or 0, stopped. Also, an object's acceleration is either positive, negative, or 0, which is the constant. Now, so what we're looking at here, when velocity is greater than 0, aka positive, right? And acceleration is positive. Acceleration is positive and velocity is positive. What is the object doing?
Oh, moving in a positive direction. Like,
I'm looking for more than that. I don't know
Right
how to
and
do it
up.
here.
oh,
Think about signs here.
it's
There's
the
only
same
positive
sign.
because they're the same sign.
Yeah.
Same sign means what? What's my particle doing?
Increasing.
This table, right?
Right, but
But it's
what is increasing, I guess? You're just saying increasing. What is it that's increasing?
speed.
Speed. So for increasing, we are increasing speed, speeding up. You guys are just saying increasing, it was throwing me off, and my brain was looking for speeding up. I guess I wasn't.
So if it's speeding up, could you say moving right? Or would you say moving up? Or would you just write speeding? Just write speeding.
Speeding up, I could handle increasing speed. Your speed is increasing. That is speeding up, yes? It's different from moving right, though. From just moving right. Okay. What about if this next one? Velocity is greater than 0, but acceleration is less than 0. Slowing down. Now, velocity is positive, but acceleration is 0.
Constant.
Okay? It's constant acceleration. And where's my velocity taking me?
To right. That's going to be right.
Constant acceleration.
And positive.
Velocity says to the right. Okay. Velocity is negative, acceleration is positive. Slowing down. Opposite signs again, right? Acceleration is negative, velocity is negative.
Speeding up.
Same sign, say we are speeding up. Velocity is negative, acceleration is 0. That means acceleration is
Constant acceleration.
constant and velocity is to the left. Okay? Velocity is 0, acceleration is positive.
Constant velocity. Acceleration.
Done.
Just slowing down. No.
Velocity of 0 means what?
It's not moving.
It's stopped. Whether it's paused and turning around, whether it's, it's stopped. Okay? Now, the acceleration being positive says that it's pushing it right or up, but there's no velocity, so it's not actually moving. Okay? Switch these around now. Well, no, velocity is still 0, so that's still going to be stopped, but negative acceleration means it's pushing it left or down. And when they're both 0, it is stopped. There is no acceleration. My BenQ needs reset. It's doing goofy stuff on my right. Okay. There's some definitions on the next page. This is probably the page I was thinking of when I was thinking about displacement and whether or not we have talked about it. It all blurs together. I can't remember what I have and haven't talked about, obviously. So there are some information here. We've talked a little bit about displacement, average velocity, velocity, speed, absolute value of velocity, distance traveled, direction changes. I'm talking about number 7. You have this chart. I would suggest you look over it and read through it, okay? 7. A model rocket is launched vertically upward from ground level with an initial velocity of 114 feet per second. The position of the rocket can be modeled by said equation. Find the velocity and speed of the rocket at t equals 5 seconds. How do I find velocity? It is the derivative of position, and that's a position function. So what is the derivative of negative 16t squared?
Negative 32.
Because you multiply the power out front, subtract 1 from the power. Are we all, that's in our brain somewhere still, right?
Just might take
Plus derivative of 114t is just 114. Now, they wanted the velocity at 5 seconds. So v of 5, negative 32 times 5 plus 114. My answer key says
46.
negative 46.
Yes, I did that in my head.
Negative 46 what? Feet per second. That is the velocity. It also asked me for speed.
Second.
What is the speed?
The absolute value of velocity.
Absolute value of velocity. So speed is
46.
positive 46 feet per second. I'm going quick. I know. Sorry. Right quickly. Okay. B. Is the rocket speeding up or slowing down at t equals 5?
slowing down. is the thing. Well, but the speed is, I don't know.
Okay, wait. We know the velocity, yes?
Yes.
The velocity at 5 is negative. What's the acceleration at 5? Have we even talked about that? No, you can't answer the question yet. So, acceleration is the derivative of velocity or the second derivative of position, correct? I just wrote a of t equals v prime of t equals s double prime of t. So what is the derivative of velocity?
Negative 32.
Derivative of negative 32t is negative 32. And that's it, yes?
Yes.
So what's the acceleration at 5?
Negative 32.
Negative 32. So what do we know?
It's slowing down because it's negative.
So
But it's on the same side.
The same side.
Okay.
It's all right, Kylie.
My rocket is speeding up
Why do I have to overcomplicate so much?
because I'm going to write this. The velocity of 5 is less than 0. And the acceleration at 5 is less than 0. Or in other words, same signs. But the official way to write same signs would be to state that they are both, in this case, less than 0. That's indicating that you understand same signs.
I would have had this last year. Oh my gosh. I would be just going.
What is the maximum height the rocket will rise? What am I looking for? How am I going to find the maximum height?
You plug just 5 into
You
position.
did it in another problem.
Because height is
Height is position, but where is that maximum height occurring? What are you plugging in? When is the maximum height occurring? When what is 0?
velocity.
We need to find when velocity is 0. Because the rocket's going up and coming down, yes. So that moment when the rocket pauses up top, not that it really pauses, but kind of looks like it, when velocity is 0. So velocity equation was negative 32t plus 114 equals 0. Magic solving, 3.5625 seconds. You could do that math, right? Yes. If you grab your calculator, that's
It has
Math.
a calculator sign, so I'm good.
yes. Now, am I done?
No.
It said what is the maximum height. So now this is when the maximum height occurs. So what do we do?
Plug that into position.
Plug 3.5625 into your position function. And I have 203.0625 feet. That's plugging into the original equation, yes? Go back and try it later if you want. What is the speed of the rocket when it hits the ground? When does the rocket hit the ground? What do we know is true when the rocket hits the ground? What is 0 when the rocket hits the ground?
Gone.
Nah,
Oh, position.
position. Besides velocity, I guess, but position. Because when the rocket hits the ground, the height of it is 0. So you would be setting negative 16t squared plus, what is it? 114t equal to 0. While I'm here, I'm going to factor a GCF of negative 2t out. Then that leaves me with 8t minus 57. Set each factor equal to 0. You would get t is 0, and you would get t is whatever 57/8 is. What is the speed of the rocket when it hits the ground? Well, it starts at 0 right here. Wait, speed, this is when it hits the ground, sorry. This is when it starts, this is when it finishes. How am I going to find speed?
You put it into that equation. The
Plug it into
velocity equation.
velocity. So you're going to do velocity of 57/8. It says speed, so I want absolute value if that applies. I have an answer of 114 if you care to know that. That's 114 feet per second. Okay? Now, I didn't get through one page. How important is it to homework? I don't remember. But work your way through homework. It's going to take a bit. I'm telling you now. Okay?
Wow.
We can finish up any issues we need to tomorrow. The guided notes key is available also. So if you want to go look at that last page in the notes, you can. Okay?
You really didn't even have to go on the definition velocity. Just velocity.
But does it always though? I didn't.
Not always, but for a lot of things it does.
Okay, and see, and that's not the way that's not how we usually teach in
Okay,
calculus.
sorry.
So